I now have two variables. I have an x and I have a y. Okay. So what's it mean to solve an equation with two variables now? Well, now I need to find two values. I need to find a value for x and a value for y that makes this a true statement. So I need to find two numbers, a pair of numbers that make this true. And so I might ask you, I don't know, could you tell me a solution of this equation? Could you find a pair of numbers that makes this true? I don't know, does anyone want to shout out what's an answer? We could try this. Anyone feeling brave? Tell me a solution to this equation.
X could equal 5 and y could equal 6.
Okay, thank you very much. That's a good one. We could do x equals 5 and y equals 6, because 5 plus 1 is definitely 6. And I could ask for another one. In fact, we know another one because of what I had on the board earlier. I'll tell you guys another one. I could do x equals -1 and y equals 0. Yeah. From what I had on the board before, we know this is a solution. -1 plus 1 is 0. So already I see I have two solutions here. And in fact, I could keep going. There's nothing special about these numbers, really. There are actually infinitely many solutions. There are infinitely many solutions. And so this ends up being our typical situation here when I have two variables. When I have two variables, our typical situation is that I have infinitely many solutions. And so the question is, how do I represent them? So there are infinitely many solutions. I would like to be able to communicate them to someone. You know, if someone gives me an equation, and they say, give me the solutions, I need to be able to tell them about the solutions somehow. But there's infinitely many, so I can't like write them down in any straightforward way. So instead, we find a clever way to represent them, and that's by drawing a line. So when we graph a line, we're actually representing the solutions to an equation with two variables, like this. Okay. So we're gonna have to talk about graphing because that's how we represent solutions to an equation with two variables. Okay. So that's what we're gonna do. That's our motivation for why we are graphing lines. So now that we know maybe why we're going to graph lines to represent solutions, let's see maybe how we're going to graph lines. And again, this is probably nothing new to you, but let's just remind ourselves how we're going to do this. We have what's called coordinate axes. Maybe the coordinate plane, either way is fine, they're synonymous. You guys will have seen something like this, and it's going to make me look a little sloppy because I'm bad at drawing. We have these two lines crossing each other. These are our axes. The horizontal one is our x-axis, and our vertical one is the y-axis. So again, we're dealing with equations with two variables. And so I want to represent those variables here in this plane. And we're just going to agree that if I move horizontally, that's corresponding to the x variable. And if I move up or down, that's going to correspond to the y variable. And then we're going to put units on here. We're going to count. And the idea is that I'm basically just counting. So this is like 1, 2, 3, so forth. If I move to the left, I'm doing negative. So it's -1, -2, -3, and so forth. And the same thing on the y-axis, up is positive, down is negative. And we're going to agree that in the center, x and y are 0. So as I move along here, it's just representing different values for my variable. And so we can represent a point or two values as a point on this plane. I could go over here. This is some point in my plane, and that point has some coordinates relative to x and y. This represents some value of x and some value of y. And in this case, I went over 3 on the x-axis, and I went up 1 on the y-axis. So the coordinates of this point are 3, 1, and 3 is the x-coordinate. I went over 3 on x, and 1 is the y-coordinate. I went up 1 on the y-axis. So we can represent any point on here with coordinates just by telling you where to go on the x-axis and where to go on the y-axis. Going there. So I could do another one over here. I don't know, maybe 1. So if I go to this point over here, starting from the middle, I went to the left 1 on the x-axis. So I went to -1 on the x-axis. And then I went up to 3 on the y-axis. So the coordinates would be -1, 3. Okay. So this is our coordinate plane. This is how we graph points using coordinates on the coordinate plane. So in your activities or something, you might be asked, you might have to draw some of these. You're going to be asked to graph lines and such. You could either have graph paper. You can like buy a graph paper. Or you can print it off on the internet. Or you could just kind of draw your own like I did here. If you draw your own, I only ask that you make sure you draw it big enough so that I can read it. I've had students in the past draw me graphs that look like this down here, and I'm sure you guys can't really interpret this. I certainly can't. It's too small. So be careful when you're drawing graphs. Make them big. You can never make them too big. You can make them too small. Don't make them too small. Make them nice and big and label your points and stuff like that. It's good to label your coordinates and things. So whenever you draw a graph, just try to make it as readable as possible. Otherwise, I won't be able to interpret what you write. So here's our coordinate axes. And this is how we're going to graph. And the question now is I've graphed a couple of points. We can graph points, no problem, just by using the coordinates. How do I graph a line is now maybe the next question. How do we graph a line? And there's a fact, which is that we're just going to kind of, none of us are, we're not robots, so we can't draw a line perfectly. So I'm really just going to ask you guys sort of sketch it as close as you can. And really all you need to do that is you just need to find 2 points on the line. If you can find 2 points on the line, then you can kind of just connect the dots. And that's a nice sketch of what the line looks like. So like in this case, I've graphed 2 lines. So if there's maybe a line that goes through those 2 points, where is it? Well, if I just kind of eyeball it, connect the dots, it looks something like this. And just draw the line through the 2 points. Here we go. Those 2 points made a line. I don't know anything about this line yet. Like, supposedly there's an equation that represents this line, and I don't know what that is yet. That's where we're going to go next, is how to find that. But I do at least know that there's a line given those 2 points. So the next question would be, how do I get an equation for that line? And that's what we want to do next. But before we do that, let's talk about a couple properties of a line. Maybe I'm going to regret erasing all this, but that's fine. And you guys can say hello to my cat, Luna. I have 3 cats, and they're probably going to get up in the camera all the time. So hopefully they won't interrupt too much. All right. So we want to talk about a couple properties of lines, maybe. And maybe the first one that we should always talk about is slope. So what's the slope of a line? A line has something called the slope. What is that? Certainly you guys have heard this phrase before. Rise over run. So you've probably been told at some point in your life that slope is rise over run. And so maybe a question is, what does that mean? And here's what this means. If I give you a line, let's draw some more coordinate axes here. I'll just plot some points. And then we will see, I don't know, 1, 2. That's fine. So here I've plotted 2 points, 3, 0, and 1, 2. Now, as I just said, there's a line between those. So I could draw the line between those 2 points. And I want to ask what the slope is. Slope is somehow rise over run. You should kind of think of it as how is this line changing as I move from left to right. So what does that mean? Well, run is what I mean by moving to the right. So by convention, let's just agree to always move to the right when we're measuring slope. So maybe if I start at one point, maybe here, and then I move to the right by 1 unit, if I will see what's happening on the line, you'll notice I started up here, but then as I move to the right 1 unit, now I'm down here. If I move to the right another unit, I've gone down even lower. So as I move from left to right, my line is going down from left to right. So the run is sort of measuring how far did I move to the right, and the rise is measuring how far up or down did the line move as I move to the right. Yeah. That's what we're capturing here by slope. So as I move to the right, the line moves down, and I want to sort of measure how much it's moving down as I move to the right. That's what we're going to do here. So to make this really explicit, we have something called the slope formula, and it looks like this. Again, it's probably something you guys have seen. But let's remind ourselves. We have a slope formula, and it goes like this. So m is slope. I'm not sure where that word comes from, or like why we use m for slope. I think I was told once that it was for the German word for slope or something like that, but I don't know if that's actually true. Anyway, m is always going to represent slope. So m, the slope of this line between the 2 points that have coordinates x1, y1, and x2, y2, is take the y coordinates and subtract them in order, y2 minus y1, and then divide by what I get when I subtract x2 and x1. Yeah. So here, the y1, y2, x1, x2 come from coordinates for the 2 points. So let's make this explicit via an example. Let's do an example here. I'll erase part of my coordinate axes. Here I have a line with 2 points. Let's find the slope of this line using our new formula. So I have 2 points. I have 1, 2, and I have 3, 0. So maybe find the slope. I could say that this is the point with x1, y1, and this is the point x2, y2. Maybe I should rewrite this so it's not crossed out by my line. This is 3, 0. So this will be x1, y1, x1, y1. This will be x2, y2. Let's plug this into our formula and find out the slope of this line. So y2 is 0, y1 is 2, x2 is 3, and x1 is 1. So I'm going to take 0 minus 2 divided by 3 minus 1 here. And now we can simplify that. 0 minus 2 is negative 2. 3 minus 1 is 2. So negative 2 divided by 2 is negative 1. So my slope is negative 1. Okay. And as you check, you can maybe sort of see it from the graph. As I move to the right by 1, my line should go down by 1 unit. So whenever a slope is negative, as I move to the right, the line should go down. If the slope was positive, then my line should go up when I go to the right. So maybe I could draw a little picture of illustrating those things. But anyways, I'll do that in a second. Let me just illustrate that this is very important, and you will be expected to know it. So we'll be familiarizing yourself with this formula. You'll get to practice it on your activity for this section. You'll definitely want to know this. Okay. And let me draw the picture to remind you. For a positive slope, your line should look like this. It should go. So for positive slope, your line should go up as you go to the right. And for negative slope, it should do the opposite. It should go down. Negative, it should go down as you move to the right. So that's a good sort of check for yourself when you do any work. Good way to check your work. If my line looks like this and you're calculating a slope, it should be positive. And if it's like this, it should be negative. So that way you can sort of check your work. Okay. So that's slope. Anyone have any questions at this point? You good?
I have a quick question.
Yes.
So it matters then which set is x1 and y1 and which one is x1 and y2. They're not interchangeable.
So that's a great question. And the answer is actually it doesn't matter.
Okay.
You can pick either point to be either one, but you just have to be consistent once you make a choice.
Okay, thanks.
No problem. So yeah, either one of them could be x1 or x2 and so forth. Any other questions? So yeah, okay. So that's slope. And that'll be very important. You know, we're always gonna have to worry about slope. And maybe one more thing to talk about before I talk about just equations, and then we can sort of move on here, is let me just remind you about, well, actually, let me do this. We'll talk about equations for a second. So your book likes to talk about the general form of an equation for a line. General form. This one's maybe not as familiar to most people. You guys doubtlessly know about slope-intercept form or point-slope form, which we'll get to in a second. But your book likes general form, and you'll see this on your activity as well. So I will tell you about what this is. Basically, it just looks like this. And I drop a marker. Looks like this. AX plus BY equals C. A, B, and C are just numbers, and X and Y are variables. We'll always use X and Y for the variables here. So A, B, and C are just numbers. So by writing different numbers, I get different lines, is the idea here. We'll get different lines for different numbers. This is called the general form because using this form, I can basically write down any line you could ever think of just by changing the numbers appropriately. And so your book likes to use this, and you'll get to explore this a little bit on your activity, some of the properties. But I want to introduce this now just so we have some equation to play with. But we'll talk about the other forms here in a second. I want to introduce one more property then, which is the idea of an intercept. So I have an x-intercept and I have a y-intercept. These are two special points that I might want to look for if I give you a line. So I might want to ask about the x-intercept or the y-intercept. And these are good names. These are exactly what they say they are. The x-intercept is where my line hits the x-axis, and the y-intercept is where my line hits the y-axis. So these are special points, and they may not exist, depends on the line. They may not be able to, they don't exist for every line. But I always want to look for them if I can. So x-intercept is where I hit the x-axis, y-intercept is where I hit the y-axis. And how can I relate this to the equation that I have? You know, how might I go about finding these? Well, if I have an equation, maybe I can use the equation to find the intercept. And so the question is, what would I have to do? Well, where would my line hit the x-axis? And so if I had my coordinate axes, where am I hitting the x-axis? If I have some line, I'll just draw in some line. Here's some random line. Here's where it hits the x-axis. What do I know about the coordinates at that point? Well, if I know, look, I'm somewhere on the x-axis. I moved to the right by some amount. So I'm somewhere on the x-axis. I don't know where. So that's not too helpful. But if I look at the y-axis, you might notice I'm actually on the x-axis, which means I'm not up or down at all. I'm right here on the axis, so that the y-coordinate had to have been 0. So the y-coordinate has to be 0 at the x-intercept. Because I'm on the x-axis, that's exactly where the y-coordinate is 0. So this is where the y coordinate equals 0. So to find it, I might go into my equation and replace y with 0, or y equals 0. We can do an example here in a second. Let's talk about the y-intercept quick. It's the same kind of thing. Here's my y-intercept. Notice it's on the y-axis. So what do I know about it? I know that at least the x-coordinate is 0, because if I'm on the y-axis, I haven't moved to the left or right at all. I'm stuck on the y-axis. So this is where x is 0. They're sort of opposites of what you would expect. X-intercept is where y is 0, and the y-intercept is where x is 0. So to find them, you can plug one of these into your equation and solve. So we could do a quick example of that. A quick example. I am recording this also, by the way. I will upload this to Canvas at the end. I think I forgot to hit record right away at the beginning, so the syllabus stuff's probably not in there. But the math stuff should be on there for this video, and I'll remember to hit record from now on. So bear that in mind. Let's see a quick example. We had that one line earlier. We had y equals x plus 1. Let's say I wanted to find the x-intercept of this. What do I need to do? The x-intercept, again, is where the y-coordinate is equal to 0. So I just need to plug in y equals 0 and then solve. So we'll just plug in y equals 0. And that gives me x plus 1 equals 0. Well, we already solved this equation, so I know that x has to be negative 1. So the x-intercept is negative 1 comma 0. That's the x-intercept. And we do the exact same kind of thing for the y-intercept. Although now instead of plugging y equals 0, we're going to plug in x equals 0. And what does that give me? If I plug in x equals 0 up here in my original equation, I get 0 plus 1 equals y. So I just get 1 equals y. I don't have to do anything here. This just tells me right away that y is 1. So my y-intercept is 0 comma 1. 0 comma 1. So any questions at this point? This is finding x and y intercepts, which you may be asked to do in an activity or something. And it's something you'll want to know how to do. This will be very helpful, actually. I'll go ahead and move on. So finding the intercepts is very helpful if I want to write down an equation for the line. If I give you like 2 points on the line. So I could give you 2 points and say, give me the equation of the line through the 2 points. And being able to find intercepts would help me do that because I have the following forms for equations of lines. So here's 2 more forms now instead of just a general form. There's point slope form, which we like. Here's point slope form. This says that the line through the point x1, y1 with slope m. So to write sound slope point form, I just need to know 1 point on the line and the slope of the line. Then I can write down the equation. It'll be y minus y1 equals m times x minus x1, like so. So this is what we call point slope form, because all you need to do is know 1 point and know the slope, point slope. Then I just fill in this equation down here. So y and x will be variables that we'll leave, and then the x1, y1 come from the point, and the m is the slope. So if I know those pieces, I can just fill in this equation and be done. So this is one way to get an equation of a line. You just need to know this information. So this one's really good if you have a problem that's in something like find the equation of a line through 2 points. Once you know 2 points, you can find the slope using the slope formula, and then you know at least one point on the line already, so you can just plug everything into this and be done. So this is a very useful formula. And again, you'll get to practice that on your activity. And then one more form to mention, which would be slope-intercept form. So the last thing to mention is slope-intercept form. Slope-intercept form. Okay, so this is the other form of an equation. It's related to point slope, but it's just a little different. This is the equation slope m and y-intercept b has an equation that looks like this. Y equals mx plus b. Y equals mx plus b. So y equals mx plus b is slope-intercept form. Again, the slope is m, and b is the y-intercept. So this is similar to point slope form in that all I need to do to write this down is know the slope and one point on the line, but it's a little different because I don't get to know any point. I have to know the y-intercept in particular. So I'm looking at a very special point. With point slope, it could be any point on the line at all. For slope-intercept, it has to be the y-intercept. So it has to be the y-intercept to be able to write it down in this way. But once you know the y-intercept and the slope, you can just write this down, and now you have an equation for your line. So this is a favorite of a lot of people. A lot of people like this form. I have many students who insist on writing their equations like this, and that's totally fine. Again, usually I'm not going to care which form you use unless the question asks you specifically to give it in slope-intercept form or something, which it might. So just read your problems carefully, but if it doesn't say which form to use, I don't really mind. You can kind of just use these three forms that we've talked about: general, point slope, or slope-intercept. Because they should all represent the same line, no matter what. Okay. This is a good point to stop for questions, if anyone has any. It's me to take a drink.
Will you clarify when the right, like when to use these specific formulas? Like, is the right time to use them?
Yes. Here, I'll make a little. So I guess we have point slope, we have general, and we have slope intercept. Maybe I could have spaced this out then. This was A, x plus by, C. This, yeah, I don't like my table. This is y minus y1 equals m, x minus x1, and this is y equals mx plus b. So the question is when to use which one. And so it'll totally, in some sense, you can use any of them, but practically speaking, yeah, it will matter which kind of problem you're doing. So it'll matter, the nature of the problem. And so let's not talk about general first. Let's talk about point slope. When can I use point slope? You'll want to use point slope if you know a point on the line and the slope. So what you need is one point and the slope. And notice I'm just saying 1 point, so it can be any point at all that's on the line. Doesn't matter which point it is. Just any point on the line and the slope, then I can use point slope. So this is good to use, say, if I give you a problem that says, here are 2 points, find the equation of the line through those 2 points. That's good because I can use the 2 points to find the slope, and then I can take one of those points, and then I can put them into this equation and be done. I'll have an equation for the line. So this is really good for finding an equation of just a line for 2 points, for example. Slope-intercept form requires 1 point in the slope, but it requires a special point. You need the y-intercept and the slope. Can't be any point, it has to be the y-intercept now. And then the slope. And if I know that information, then I can write this one down. As far as finding equations, maybe this one is almost easier because you just directly plug in for point slope form, a point and the slope, and you're kind of done. You don't have to do anything. Here, you may not know the y-intercept right off the bat. And so maybe you need to start here and then sort of solve to get this one. I don't know. Maybe sometimes this one seems less practical, but actually this one is really nice. Maybe I could show you an example tomorrow. Maybe I'll do that. This version of it is very nice for graphing. So the slope-intercept form is great for graphing because I sort of get a starting point at the y-intercept, and then the slope will tell me where the next points should be, and I can fill in the line. So this one is easier to get an equation for, but this one, if I have an equation, it's easier to get the line. Very nice to get the graph line. General form is just kind of its own general thing that you should just be aware of, but let's not worry too much about when to use it. Practically speaking, you guys are probably going to like these two the most. Yeah. So I know I do. I never use general form. I just have to tell you because it shows up in our activity. Anyway. Okay, any other questions? Okay. Okay. So maybe that's all I want to say about math right now, for the moment.